So the final classification model evaluation metric we're going to have a look at is a classification report. And now, really, a classification report is also a collection of different evaluation metrics rather than a single one. So that's where the report comes from. It's kind of a report back of a number of different parameters evaluating our classification model. Let's see one in action. So from sklearn.metrics, import classification report. To do it, we just pass it some true labels, aka yTest, and some predictions. So once again, this evaluation metric is just comparing the true labels of our data versus the predictions that our model has made. So let's see what happens here. All right, there's a fair few things going on. We got precision, recall, F1 score, support, 0, maybe that's for the class 0, for not heart disease, 1, maybe that's for heart disease. If we come down, we got accuracy, 0.75, macro average, weighted average. What's going on here? Well, let's go to our Keynote and have a look at our classification report anatomy. So over here, we see we've got the same thing, so just import classification report. We've done one on the test labels and the predictions. Some slightly different numbers here, what's in our notebook, but that's okay. So what's precision? Well, precision indicates the proportion of positive identifications, so aka the model predicted class 1, which were actually correct. Now, a model which produces no false positives has a precision of 1. So that's where we can see our precision scores. If the model produced no false positives, and we know that our model hasn't because we've looked at the classification or the confusion matrix and we've seen it confused on some examples and it's predicted them as false positives. So our precision scores are a little bit lower than 1. Now, the next one is recall. So recall indicates the proportion of actual positives which were correctly classified. Now, a model which produces no false negatives has a recall of 1.0. And again, we know from our confusion matrix that this isn't the case. So our recall is a little bit lower. Now, our F1 score, a combination of precision and recall. A perfect model achieves an F1 score of 1.0. Okay, so we see our F1 score is not 1.0, but it's still relatively high. Then if we go support, the number of samples each metric was calculated on. So we see here, so this means we look at this, 29. So if we look at that, that's for 0. And down here it's 61. So that means that these metrics here were calculated on 61 different samples. And these metrics along here were calculated on 29 samples which had the class label 0. And that this one is 32 with the class label 1, aka has heart disease. And so if you total these up, 29 plus 32, you get 61. Now, accuracy, we've seen that before. This is just the accuracy of the model in decimal form. Perfect accuracy is 1.0, aka our model is making predictions right 100% of the time if its accuracy is 1.0. Then we have a look at macro average. Now, what is that? It's short for macro average, as you may have guessed. So it's the average precision, recall, and F1 scores between classes. Now, the key here is macro average doesn't take class imbalance into, this should be effect, into or account. So pretend this is a count. So if you do have class imbalances, pay attention to this metric. Okay, so in our case, what is a class imbalance? Well, if you look at our example, we don't have class imbalances here. Why is that? Well, because we have relatively the same amount of samples with class 0 and class 1. Meaning, we've got about 50-50 split here. It's not exactly 50-50, but it's not like we have 60 examples of class 1 and 1 example of class 0. So we've got about 30 in each. So if you did have class imbalances, you really want to check out your macro average. Now, because our example, the classes are relatively balanced, that's why the macro average and the weighted average, short for weighted average, AVG, the weighted average is the precision, recall, and F1 score between classes. Weighted means each metric is calculated with respect to how many samples are in each class. So this metric will favor the majority class. For example, will give a high value when one class outperforms another due to having more samples. So this is why that our values here are quite similar, because we have balanced classes. Now you might be thinking is what kind of situation would it be that these values would be out of whack, right? Like where would this happen? And you might also be thinking, we've learned a whole bunch of different metrics here. If we come back to our notebook, we've gone over classification reports, we've done confusion matrix, we've done accuracy, we've done area under ROC curve. So when should I use each of these? So now we've kind of gone through them, it might be tempting to think, well, why don't I just ditch all these other ones that I really am having kind of trouble grasping and just use accuracy? Well, let's have an example. Let's see when other metrics come into play and maybe you shouldn't just use accuracy. Because this is a trap that I got caught in, right? When I first started building classification models, I was like, yes, my model is getting 90+% accuracy. It must be a great model. Let's see a scenario. So for example, let's say there were 10,000 people and one of them had a disease and you're asked to build a model to predict who has it. All right? So let's actually do that. Let's code this up. So this is where precision and recall become valuable. And in fact, all the metrics in our classification report become valuable here. So disease, true. So there was 10,000 people and one of them had a disease. So what we might do is create a NumPy array of 10,000 people. And then we might change one of these. If I can spell disease. So disease 0th index equals 1. So there's only one positive case. Then if we come down here and say our model predicted or disease preds equals NP zeros 10,000. Now this means model predicts every case as 0. All right. And then what we're going to do is create a PD data frame so we can visualize this. Classification report. What if that's what our model did, right? This is what's happening here. Disease true. So there's only one positive case, 1 in 10,000. And we build a model and our model predicts that every single case is 0. So it misses the one prediction. What would happen if we build a classification report? So we go disease true. We go over here. Disease preds. We want to pass this little parameter so it fits nicely into our data frame. So output dict equals true. All right. So what's happening here? If we look at this, this is just another format of this classification report up here. If we didn't do this, it would error out. So this is just to visualize what's going on. True. So this is a prime example, right, of where you want to use another metric other than accuracy, is when you have a very large class imbalance. So in our case, we have a massive class imbalance because in our original data set, disease equals true, there's only one example. So only one example of where the label would be 1 and everything else is 0. We've built a model that just predicts 0 for every case, right? Because it's only one sample, so it's really hard to learn that there's a pattern there for this one particular case. And so what happens is, if we were to measure just accuracy on our model that has predicted 0 for everything, it comes out with an accuracy of 0.99, or in other words, 99%. And so ask yourself, although the model achieves 99.99% accuracy, is the model still useful, right? That's where we look at these other metrics, such as the macro average. That's where we can see, okay, our model's falling down here on the precision. It's actually getting 0 precision for class 1, which makes sense because it didn't even predict class 1. And here, it's getting basically 100% on class 0 because it has only predicted class 0. So this is a kind of use case scenario of where you want to make sure that you're using a wide spectrum of evaluation metrics for your classification models and not just accuracy. And now we've only just touched on some of the metrics that you can use for evaluating a classification algorithm, but there are a few more. So if you want to have a look at more, so we go here, model evaluation, scikit-learn. We'll look at the documentation. If you come in here, this is a little bit of extracurricular, is to have a look at this section here. So all I've done is gone into the scikit-learn documentation for model evaluation. We come to classification. We can see a few here, the ones that we've covered. And so the ones that we've covered are probably the bare minimum that you want to use, right? So accuracy, area under the ROC curve or AUC, confusion matrix, and classification report. So keep those in your tool bag, and if you need more, be sure to refer to the documentation. So that's going to wrap up our classification specific evaluation metrics. Let's dive into the next section where we'll have a look at some more specific regression model evaluation metrics.